Hi everyone, welcome back to another session. Currently, we are doing the MLOps Basics series, which is based on the blogs written by Raviraja Ganta. So we have done 7 sessions till now, and this is the 8th session. In week 4, we are going to discuss the model packaging using ONNX. So exactly why do we need model packaging? Models can be used, models in real life can be built using any machine learning framework out there. But a lot of times it happens that we might want to deploy these models in different environments or want to run these things with different frameworks. And if you start doing those things, you'll realize when you are doing the same thing in different environments, things start to break up. When you want to run the same model in different framework, it's like you will create wrappers around it, and a lot of times it becomes so complex and so time consuming that most of the things do not work. You face a lot of challenges. So there was a need to standardize that process and standardize that process or standardize those models, and that packaging of models and creating a wrapper around it is what ONNX help us to do. So it's a common file format that enable the AI developers, to use models with a variety of frameworks, tools, runtimes, compilers to help us out. So in this particular session, I'm going to cover the few basic things. What is ONNX? How do we convert a trained model to ONNX format? What is ONNX runtime? And how to run ONNX converted model in ONNX runtime? And then finally, the comparisons. So as I told you earlier, what exactly is ONNX? ONNX is a open format built to represent machine learning models. And since ONNX help us standardize the machine learning models, it helps us in defining a common or standard set of operators, the which are the building blocks of any ML or deep learning models, and a common file format to enable AI developers to use these models with variety of frameworks, tools, runtimes, and compilers. So, for example, we have created one model in PyTorch, and then we export that particular model to ONNX, and then now for this particular model that we have converted to into ONNX, we can inference this thing with ONNX runtime. We can inference this thing with TensorFlow or CAF or any other format that we want, but like a major format. And it kind of the basically where ONNX is helping us is kind of like extend increasing the extensibility. It's like you have built a model, now you can choose the right framework for the task that you have. And the framework, what you have built in particular framework, some models might not be able, you cannot build in those particular, or it might be hard to build in that particular framework. So you can pull out a model from different framework and work on innovative enhancements and extensibility. And then a lot of times, when hardware comes into play, a lot of times you do not have that much. There are a lot of other factors that start coming, and ONNX is something that helps you streamline those optimizations. And when it comes to hardware, one of the main advantages of ONNX is it helps to, this format helps to deploy the various models that we have on cloud for platforms as well as the IoT devices. So the second part comes in, we understood like ONNX is helpful when we are in a machine learning lifecycle journey. But how do we convert a trained model to an ONNX format? And we'll discuss this process step by step, and let me reassure you it's a very easy process. So for example, what we are having earlier is our model path is this path where we have checkpoint the best model that we have while training, and then for the model that we have, the cola model we have loaded from that particular checkpoint. Next is the input to batch where we are passing the train data loader, and then input samples we are passing two things: input IDs and the attention mask. Uh, for example, like a lot of people might not be familiar with attention mask. They can go back and see these things. But basically, attention mask is something that is helping our transformer models to see, particularly uh, since the different inputs that we have vary differently in sizes, and to standardize those sizes, a padding is added at the end of every sentence to make it streamlined in the same length sentence. And what attention mask does is it tells the transformer models that we have, that where is padding and where is the text that we have, so that while we are performing attention, while we are taking the mechanism of attention, the model is able to focus on the right words, not exactly, and not give too much importance to the padding that we have. So moving forward, we tell about input names, output names, dynamic yeah. So in this like you can see how easy it is, like if we are exporting this model using the PyTorch. So in this we mention what's the model that we have run, the inputs that we have, the from where it will save the model, then parameters, onset version, input names, output, dynamic access, variable length access, like input is come from here, attention mask is batch size, output is also batch size. So one of the things is like if you are using PyTorch Lightning, it's way more easy. It's way more standardized. You just do model to NX, ONNX, then model.onx, where to particularly save the model. Like we'll save this ONNX model in the model directory and by the name ONNX, and then we pass input sample export, input dynamic access, variable length access, and that's it. And now the thing is like that's it. That was like 5 or 6 lines of code to convert our model into an ONNX format. Now, what ONNX runtime helps us is like ONNX runtime is a performance-focused inference engine for ONNX models, and it was designed to focus on performance and scalability in order to support heavy workload in high-scale production scenarios. And it also, what I told earlier, it also has extensibility options for compatibility with emerging hardware developments, and everything is kind of compatible with this ONNX formats. For example, CPUs, GPUs, FPGA, and NPUs. So for ONNX runtime, what we generally do is we'll just install ONNX runtime, and then from ONNX runtime we will import providers and print all the providers that we have. So it shows like TensorRT, CUDA, MAGraph, Open, YNA, and all the others that we have. And then finally, how do we run that ONNX converted model into ONNX runtime? In this first, we are importing the ONNX runtime, and then we are creating one instance session. And in this, we are passing the ONNX model path. I think we would have defined the ONNX model path somewhere something like model dot. I think this was the path. And then ONNX runtime session, the inputs that we have is like the other input IDs and the attention mask. And for running the session, we will run ONNX what the output equals to ONNX runtime session dot run, and then pass the inputs. So now none will return. So we are not returning any output if the model return multiple outputs. We will specify the output name, and it particularly will return only those outputs. So if we see an example like what the full code that we have till now with and how it changes with the ONNX runtime, it's like very easy to understand. So when we are doing initializing, so we are initializing an ONNX runtime session. We are also passing the model path. The processor is like a data that we are passing, the labels, what are our final labels, like whether the sentence is grammatically correct or incorrect. And then in the predict, we are saying like the inference sample is we are passing inference sample, then process like we are doing normal processing, and then we are doing the ONNX runtime inputs in which we are passing the input IDs and attention mask. And then we are seeing like the output of this thing is like a none comma ort inputs. And then I think it's not going to pass it, give us any outputs, but like for getting those outputs, we are just doing this thing like from scores, like from this particular thing, it's not going to print anything, and none will get us all the outputs. I think I kind of said something not right. So yeah, if you mention none here, it will return all the outputs. And if the model return multiple outputs, specifying the output name here will only return that particular output. So it returned all our output, and we just took, I think, the first part of that, and from that we'll find the scores, and from the scores we can see what was the label and what was the score for that particular prediction. And then finally, one of the things is ONNX runtime help us reduce the runtime and increase the scalability. So for example, if we were running this particular model, it was taking this much time with PyTorch. However, when we were serving that model in inference with ONNX runtime, it was taking this much time. So exactly here you can see we are taking around, this thing is taking around one third of the time that was taking with PyTorch. And it's like just making a simple change did improvement by 2 to 3x in our performance. So yeah, that's it for this session, and thank you for joining. In case of any doubts, please put in the comments, and we will meet you in the next session. Thank you.